welcome to some more algebra going on. So, what do you think? Are you ready? Is this the way to get going? Come on, let's just. And then you're like, come on, we're gonna do some algebra. okay, it's probably a little bit too much. So, let's get into what we're doing. Or was it too much? Okay, so we're looking at simplifying exponential fractions, and there are a few examples here, 3 on here and 4. We're not going to go through every one in detail, but just look at kind of a concept to simplify these perhaps complicated looking fractions. And the key thing that we need to ask, forget like it says type 1, type 2. It's not like, oh, was it a type 1, was it a type 2? How many terms? That's the key question that's going to come up each time. So let's start with this first example. Let's call it A. How many terms are there in the numerator? Well, there's just one term in the numerator because there's multiplication, exponents, but not adding anything or subtracting. So we've just got the one term there. How many terms in the denominator? Well, 1. So in neither the numerator nor the denominator are there more than one term. Is there more than one term? Wow, are there multiple terms? So what we're going to do then is prime factorize and go from there. So this is already a prime base, right? 2 to the 2n minus 1. Now, I'm going to give some more space here. 4 is certainly not a prime number. How could we write 4 as a product of prime numbers or a prime base to the power of something? Well, 4 is just 2 squared, right? So 2 squared is this part here. And we're raising that to the power of n plus 1, the whole thing. And 2 is just 2. I like to use multiplication signs myself instead of these dots. Otherwise it looks like comma 2. And 2 is 2 to the 1. Sometimes it's handy to put that 1 just in case. Okay, 16. We can write 16. So it's 16 to the n something. And just as a kind of reminder hint, there it is, our calculator. If we want to find out and we want to prime factorize 16 using our calculator, do you know how to do it? Well, we can press this fact button, which is in yellow, so we can go shift, fact, and look at that, 2 to the 4. Just a nice little one in case we have, lost our minds on something as simple as 16, but it's there, right? So 2 to the 4. Now life is dandy because we've got 2 to the 2n minus 1 times, and this is one part just that it's so easy to make a little trip up on. Remember that we're multiplying this by the whole thing. So we're going 2 times n plus 1 like that. So we need to multiply the 2 by both. So it's 2n plus 2. Just an easy spot to kind of make a little bit of a careless mistake, slip on that banana, and so we go 2 to the 4n. Now from here you should be good to go, right? You can add these and then subtract. You can see that the 2n is going to be 2n plus 2n over that 4n is going to cancel nicely. That minus 1 and that 1's going to kind of cancel nicely. And whenever I say cancel, just imagine I'm putting these big ugly air quotes. And so you're just left with 2 squared, which is 4. Right, and we could check that works. But from there you should be good. So we're just going to focus on the first step here. How many terms in the numerator? Well, 1, I guess I told you. Numerator, there it is. So in the numerator we got 1. Denominator, clearly just the 1 term. So therefore we're going to go, cool, just prime factorize and go from there. So we've got 2 to the 2n minus 1 already times 6. How are we going to write 6 as a product of prime numbers? Well, clearly just 2 times 3 and to the minus n plus 1, 27, 18, again, nice little 1 to go. Well, remember we can just go 18 equals shift fact 2 times 3 squared. Not a cheat. Maybe it is a cheat. Do you think it's a little cheat to use your calculator like that? Well, if it is, great stuff. 2 times 3 squared to the n. Okay, and this was probably like 3 cubed or something. Okay, so you already know how to do this. You've done the first exercise and cruise through. So you're going to have each of these to the minus n plus 1, and from there, hopefully, good to go. Cancel, add exponents, etc., etc. Okay, so same idea over here. I don't think there's much new in this one at all. We've got 12, so we got whatever 12 is. 2 squared times 3, I think, 4 times 3. Okay, pause. All good? Okay, and if you came back with a no, not all good, then I'm going to see that. So at the moment, I'm running along Danley going, well, hopefully you said all good. Maybe hopefully you didn't say all good and there's still something there you want to grapple with. And maybe once you've tried some of the exercise, you'll get there. Okay, so the next one here. That is, how many terms do we have in the numerator in this first one? Well, this time we've got 2 terms. Here's a term and here's another term. And in the denominator, we've also got 2 terms. So if in either the numerator or the denominator, there are 2 terms, new strategy. And this approach we're calling split and factorize. So what we mean by that, let's run through one together quite carefully. Okay, so 7 times 2 to the x, cool, minus 3 times. Now here's the split. If I asked you to simplify 2 to the x times 2 to the 1, could you simplify that? Well, with a bit of luck you went, oh, the bases are the same, we're multiplying, so we added exponents. Now we're going to do the opposite. So we're going to start on, oh no, I can't reach that high. But we're going to start that side and we're going to go that side. So we're going to start with the 2 to the x plus 1 and we're going to go back to that. So we've got 2 to the x times 2 to the 1. Quick pause. Okay. Denominator, 2 to the x minus. How are you feeling on splitting this 2 to the x minus 1? Okay, well, I would go x minus 1. Right, we're multiplying, bases are the same, x minus 1. Now what can hopefully jump out is, hey, look at this numerator. Just looking at the numerator. Is there something common to both those terms? Can we factorize it? Oh, there's a 2 to the x here, and there's a 2 to the x here. So we can take that out as a common factor. There were 2 terms, so there must be 2 terms in this bracket. We need to multiply it by 7. Because look, 2 to the x times 7 is 2 to the x times 7. What do we have left here? Minus 3 times 2 to the 1. So if you multiply this and you get this. Oh, in the denominator, 2 to the x, 2 to the x. 2 terms here. So once we've taken out our 2 to the x, they're going to be 2 terms left in the bracket. What are those 2 terms? 1 minus 2 to the minus 1. Okay, and that's really what we want to see. So, and we want to see this going, oh, how many terms are in the numerator in this now? Well, it's just 1 now. Because we got something times something else. So therefore, how many terms in the denominator? Also 1. So we can go, excellent, cancel those because it's 1 term over 1 term. We can cancel. This stuff here, straight into the beloved calculator to go, well, if the calculator, let's see, oh, I don't know if I can move this on the fly. Look at that. So the calculator is there, and so we can put in that fraction and say 7 minus 3 times 2 over 1 minus a half. And we get 2. Great stuff. Okay, because what we're working on here is this idea of splitting, factorizing, and getting an answer. Not working with these numbers, these pesky numbers. Okay, let's put our calculator back in that corner. And get rid of it. Okay, so there we are. There's our idea, split and factorize. So in this one here, we could split 5 to the x minus 1, 5 to the x times 5 to the minus 1. plus 5 to the x times 5 squared, 5 to the x times 5 to the 1, common factor, 5 to the x, and so it goes. Here, multiply this in maybe, see how you do, 2 to the n. Oh, this one looks like the only thing I would think about here is, sure, it might be worthwhile just seeing if we can simplify that a bit. We've got 4 times 2 to the n minus 3. How could we maybe look at simplifying that? Yeah, I'd say that this 4 we could write as 2 squared times 2 to the n minus 3. So at least we could have 2 to the n minus 1, which we could then split to that. That looks a little bit simpler than this. It will probably all come out in the wash. So there we go. Feeling like you can try that exercise too. Any in particular that you want to go through here, you can either pop it in now or just pop it as a private comment back to the assignment that this is on, and enjoy exercise 2. If it takes you a little while, we've still got tomorrow to do a few more of these. So yeah, work on it now for the rest of the lesson for you tonight, and let's take it from there. You'll have a chance to do a few more after that. Enjoy, and should we get back to things? What happened to our music?